the best way to get a durable structure. Now, occasionally, I will talk in the US to Department of Transportation officials. In the US, they're very keen on doing accelerated bridge construction, because I don't know if you heard, bridges in the US are in a real bad state of repair. So they're very interested in fast forms of building a bridge. So we propose sheet pile in the abutment because it's the fastest and lowest cost way of constructing a bridge, believe it or not. It replaces all the concrete. And they invariably will say to us, look, we would never go with steel because steel has a maintenance cost, concrete doesn't, and we can't budget for that cost. So my answer is, well, look, how wonderful it is to be able to know at any point in your structure's life how much life you have actually got left. And you can do that with steel. We have looked at replacing circular columns precast with a steel tube. And what jumped out at us was the fact that there is less steel in the steel pipe than there is in the rebar in the concrete in this. And as the design codes have become more rigorous for seismic conditions, the amount of rebar in these columns has just increased. It's so dense that it's very hard to get the rebar into the formwork to pour the concrete. And they've had to reduce the aggregate size that goes into the concrete mix so that they can get the concrete to pour itself around the steel rebar. It's that bad. In effect, what you have is the reinforcement is carrying the loads of the structure. The concrete is simply the cement paste that's holding it all together. It's kind of what you got. Once the rebar is included, embedded in that concrete, it can no longer be inspected, it can no longer be maintained. It's in there. Once the corrosion process has begun, that we looked at just a few seconds ago, once that's begun, it's trapped in there by the cement paste as it wraps itself around the steel, continuously, can't avoid it. And when the concrete inspector comes along to the site and looks at the project, and he taps the concrete, and he ticks it off, and he says, it's okay, it's fine. He hasn't got the foggiest idea what's going on inside that concrete structure. And he will tick it off as if there is no problem at all. You can't see it. It's not that concrete doesn't corrode, it does. It's just that you can't maintain it, so you don't. And that's the big issue. How do you monitor the degree of carbonation that is going on inside a concrete structure? You can't. So you don't, and you ignore it. And you ignore it right until you get to this state, failure. So don't tell me that steel has a maintenance cost and concrete doesn't. Concrete does have a maintenance cost, it's just no one knows how to do it, so it's ignored. So design the steel to have the design life that you want. Allow it to corrode all the way through because you have that sacrificial thickness. And then you have an equivalent solution. And then I came across this. It was produced by the Port of Long Beach. It's wharf design criteria, and it's a fantastic document. For anybody who is designing port structures, for all those engineers out there, they really take this to heart. It's beautifully laid out, right up until you get to chapter 5 on piling. The standard conch pile is a 24-inch octagonal precast pre-stressed concrete pile. The use of steel piles is strongly discouraged due to the corrosion potential and the associated higher maintenance cost. Well, what maintenance cost is that we're talking about? Is it a maintenance cost that you're unable to get into and understand? Additionally, corrosion barrier coating systems and encasements impede routine visual pile inspections. Steel piles should only be used when project criteria and site circumstances dictate. Corrosion barrier coating systems and encasements impede routine visual pile inspection. Excuse me? But isn't that exactly what concrete is doing? Isn't concrete just doing exactly that? So here's the way I rewrite this paragraph. Beg your pardon, too fast. The use of steel piles is encouraged as the corrosion potential and maintenance cost are identical to concrete. Additional corrosion barrier coating systems and encasements can be used to extend steel life. Steel piles should be considered along with concrete on every project. Now, I'm a steel guy, and I would say all this, so please forgive me if I offend anybody with my logic on this. It brings us right back. If we've got a steel solution and steel is okay because we feel it's valuable, then the use of the O-pile system in this kind of configuration. The use of the O-pile system for the new breed of high-capacity cranes in the modern port structures is probably the most efficient solution that you can get. Thank you very much.
Thank you, Gerry. Very good. Gerry or Gerry? Gerry. Oh, sorry. Yeah. A question to the floor. Are there any cement manufacturers here? Okay, we've been brainwashed. Steel is brilliant, right? Yeah. So, question. We have a question over here. Yeah.
Of course, not from the steel cement manufacturer. But Gerry, you have done any life cycle comparison with concrete piling and the steel piling?
Life cycle comparison?
Also, another issue is like, when most of the time you see the concrete structure, when a big ship comes and hits, and you have a partial damage. So as per the code, they can replace the partial part, damaged part. But when your wiring system, steel, what do you have? Can it be done? Or,
yeah, sure. Let me take the last one first. So on a collision by a vessel, it depends on the location of the damage. If it's above the waterline, that's very easy to repair because you can extract the component of the pile and put in a new one. And it's very easy to put a little temporary limpet dam around the damaged area so you can have a dry excavation and you can go in there and do a little repair. The nice thing about steel is if it's just dented in or you have a hole, you can plate it up very easily. You can weld the plate and patch it up very, very quickly. You don't have to pour anything, you don't have to wait for it to set. If it's below the waterline and it's a serious impact, then you have to look at it more seriously. You'd have to put a bigger cofferdam around the area and do a big excavation and pull the pile out. But because it's all component pieces, you can't take out a component and put a new one in. Okay. And on your first point on the life cycle costs, well, the way I approach steel is we design it for a lifespan. So when you design concrete, you don't do that. You actually design it to be as dense as you can get it because you want it strong and you want to reduce the porosity as much as you can for the reasons I explained. But you don't define a life, you just hope it gets there. And you automatically think, well, it's going to last much longer than steel. And in fact, in many structures in the US, the reason they've got bridge problems is because the design lives are not being reached on the bridge designs. Concrete is breaking down before it gets to 75 years, and that's kind of the issue. But with steel, you define the design life. You work to a 75-year design life, and you build it in by sacrificial thickness, by coating, by cathodic protection, by higher yield steel. So it's a different way of doing the same thing.
Any questions? Well, I have a question, not related to ports, but tall buildings. Now, excuse my ignorance, yeah? I always generally tend to see concrete tall buildings, so will we see more steel tall buildings?
Well, I think there's a lot of steel tall buildings, but here's what's very interesting. Steel tall building, high-rise, can go up in concrete just as quickly as it goes up in steel. There's no advantage. But where steel has a real advantage is in 0 to 10 stories, because the fabrication is so much faster. Once you get beyond 10 stories, concrete is just the advantage of steel. There's no difference. And then you get into, well, how does it behave in terms of a seismic situation? And that's a design issue, you know, and there's arguments on both sides. Yeah.
Well, the take-home message is steel is great.
Fantastic.
Yeah, fantastic. Well, thank you, Gerry, for a very insightful presentation.